Good morning, everybody, ladies and gentlemen. Thank you for stepping in to listen to what we can share from Halliburton. My name is Sam Abraham, and I am the Global Technical Advisor for Halliburton on Geothermal specific. Also, I see familiar faces out here. What I'm going to share about is a little bit on drilling bits, but what I can say from the familiar faces is how do you use these bits properly, and what are the tools that you need. Bits is one part of it, but there's a whole aspect of what you drill. And for those of you all who are listening, everybody can drill a hole in the ground. I spoke this yesterday. But what you're looking for is to drill a well in the ground, number one. And number two is get the deliverables, what you're drilling for. For example, if you see in the aspect of geothermal here in Taiwan, mainly if you look at the wells that are there, you're looking at some of it probably is on the borderline of being a conventional geothermal well, where you've got some hydrothermal resources, or you're going to EGS projects. AGS I won't touch there, but EGS and AGS projects and conventional projects. Now, what is very critical in this is you've got a rig. First of all, selecting a rig is quite important, mainly because here you're talking of drilling to depths of 3,000 to 4,000 meters deep, number one. Number two, some of them are vertical, but some of them are also going to be directional and maybe even go horizontal for a long distance. Now, the formations over here are pretty volcanic, and also you find a lot of intercalations of formations. When I say intercalations is you find layers. Many times in some of the wells you are looking for homogeneous formations, but nowadays you find intercalations where you've got a hard formation, soft formation, and how do you drill through those. Now, when you select a bit, what are you looking for? Your main challenge or what you're looking forward is, can I drill one bit and one section? However deep that section is a different story. Now, why is this very critical? Because every time you drill a well or a section of the hole, you have to reach to the TD of that section before you run casing. The number of times increase when you change or pull out to change a bit, it's going to cost you time. And if you're going to cost time, that's going to cost you money. Plus, what type of bit are you selecting? Sometimes there are formations, say in Taiwan, okay, I might call up a drilling bit company, can you provide me a bit? And we will say, Sam, the first question is, Sam, what do you have for offset data? Now, many a times in new areas, you may not have offset data. So you have to make a few assumptions over there. So when you look at, say, for example, I'm now referring to Taiwan as a whole, or this region, you're looking at highly interbedded formations, number one, then hard volcanic rock. These rocks, some of the minerals in those rocks, I can almost bet you, we've seen some of these minerals that chip away a PDC bit, and give it about 2 or 3 hours, the PDC bit comes out like probably no hair on the head. Now, also you find metamorphic rocks. Now, one of the other things that you have to always consider is that for a long time, when I started drilling back in 1991, if you were to tell anybody I'm going to use a PDC bit to drill a geothermal well, say, Sam, no, that's not possible. We had to change that concept quite a long time. It took some time. Finally, we have been able to change it. And what we are doing in Halliburton is also trying to apply these same standards. For example, I worked a lot on the Forge project in the US. That's the Frontier Observatory for Research in Geothermal Engineering. what they did under the Department of Energy is finding rocks, finding bits that can drill through uniform granitic rock to get to a certain TD. But here now what I wanted to focus today on is, yes, if the rock was very homogeneous, I would be talking a different story. But here, the rock is not homogeneous. It's an intercalation of formations. So here, selecting a bit to match a formation is a challenge. Plus, keep in mind, your bit selection is quite important because before your bit actually touches the ground, the fluid flowing through the formation starts to make an impact on the formation before it actually touches the ground. So here comes your hydraulics, bit hydraulics also. Now, one of the things that Halliburton came up is with, especially in the Southeast Asian region, we looked at directional bits, especially using PDC bits. I'll show you something, for example. So here you see these bits where you've got either 7 blades or 9 blades, number one. Then you see the arrangement of the teeth on the rows. And then what you're looking for is in this main thing, 2 things. One is your depth of your cut. The second is the hole being in gauge. Many times what happens, these outer gauge rows are the ones that sees a lot of impact on the formation, from the formation. And then when you drill geothermal wells, the other challenge is that you lose circulation at times. Now, what is the main challenge over there? When you're drilling, you know, you guys are everybody who does some work at home, cutting things at home, right? So if you put some water, it helps to cut things better. Now, that's what also gives us a little bit of buoyancy factor and some protection from that, all the vibration. But the moment you lose your fluid in the hole, what have you done? Your buoyancy, anything that's giving it support is all gone. So your now lateral vibrations are going to increase more. Now, if you see here, we have just taken a few examples of what we have seen in these pits. Now, if you see, for example, here, you can see these cutters, especially on the center part of the wellbore of the bit, it's still pretty good. You see, starting towards the edges of the bit, you start seeing chips and things like that. Here in New Zealand, we drill through a formation called Grey Wacky, which is very much igneous or a metamorphic, almost going to an igneous type of rock system. Then, one of the challenges here is, how do you, now comes the challenge in geothermal wells, especially when we are talking of EGS projects, you are trying to drill not vertical wells, but directional. Now in directional wells, when we use things like MWD and LWD, you want to make the direction or the hole that you are drilling to be very smooth in your trajectory. But many a times what happens, you start seeing dog legs. Means what happens? You build an angle, then it drops. You build angle, it drops. So when you're having that dog leg severity, you start seeing a lot of lateral vibrations and effects of that on your bit itself. Now, when you drill long laterals, when I say lateral, short laterals will drill, after drill a vertical section, then we go so maybe 300-400 feet. But now we are talking of geothermal wells where we're talking of almost 1,000 to 2,000 feet depth in the lateral. If you have seen, some of you all might have seen Ever, Furbo showing their well designs where they want to drill true laterals almost 1,000 to 2,000 feet apart long and then want to communicate between these two wells. So those again add challenges to how can you clean those holes. Very important there is when you are drilling those lateral sections, what happens there is hole cleaning becomes a very big issue. If you do not clean your holes properly, then you have a problem of getting stuck very soon. I'm sure drilling guys will tell me that, will agree to that. You start drilling the holes, you start losing circulation, your cuttings are building up in that low side of the hole. And very soon, if you all have not drilled these type of wells, let me tell you one thing. As a driller, watch your brakes. Watch that gauge on the torque starting to rise up. Because these cuttings are piling up behind you. If you do not clean your hole properly, if your cuttings are not transported, you're ready to get stuck at that point. Then, one of the most important things is you want to reduce the number of trips that you do on your well. Why is that very important? Two things. That helps you to cut down your drilling days. Because every day that you drill on a well, what is your average cost of drilling per day? Any guesses? Okay, I'll give an answer. It's about $50,000 to $75,000 per day of everything on that well. So the more number of even hours that you spend on a bit, it's going to cost you more. Then, when you reduce your trip time, that's also helping to reduce wear and tear on your formation and on your drill string itself. What are the operational impacts? You have got both vibrations and your curve as you build your angle. I won't go too detail into that. Here again, one thing here is this type of bits helps you in directional course, building a directional course much more smoother. Why? Because the bits are shorter in length, and that helps you to control that. And stable bits in terms of vibration not being affecting it. I won't take much time here. Just I wanted to show here is, if you see the amount of build rate, here it's much lower, but here it gives you much better dogleg severity sensitivity when you're using these type of bits. Also, it helps you, these pads that are there, helps you to drill a better gauge hole. Now, what do I mean by a gauge hole? A gauge hole is, suppose you're drilling a 12¼ inch bit, hole size, okay? It drills a certain hole. But if your gauges are not protected, gradually as you go through the life of the bit starts to become a bit smaller. So what happens there, you may be thinking you're drilling a 12¼ inch hole, but slowly as it's gone down, it's probably gone down to about a 1/4 inch less. Now why is that very important? When you pick up the new bit, that's 12¼ inch hole, it has to first clean out the previous whole section and then go and drill the new section. So then people may say, hey Sam, I thought your bit was going to give me 500 meters for this bit, but it only gave me 400 meters. Why? Because you had to go and spend additional time drilling that other section. So this is why sometimes selecting a bit, having the different parameters is quite critical and very important. Halliburton has run these in different formations in different parts of the world. I won't go too much. I'll just like to focus on, this is again what we did in terms of the goal that we had when we selected the client along with us in a collaborative manner, selected a bit. What did we achieve in that? Our goal was to complete that section, 1 BHA, 1 run. And the second is to increase the ROP. Both these were achieved. One is you drill that section in 1 bit, and the second thing is your ROP was much better. Here again, it's a combination of factors that we make, but most important is a bit that you select. There's the answer to that. 30% increase in ROP, number one, and we had an offset well there that was helpful for us so that we could sort of gauge what we need to run in this well. One of the onshore areas in Asia Pacific, again, we have replicated the same. So what did we do here? We anticipated that this bit would drill up to about 1,000 meters. And actually we exceeded the plan that we had, and we could do it better. So what did we achieve? We achieved 44% increase in footage and about 9% faster ROP. But let me remind you all of one thing. Whenever you are choosing a bit, let ROP not be one of your criteria, But more important is drilling a proper hole in gauge, having your hole cleaned properly, and then making it to the next section. Because if you do not do that, sometimes I've had clients, I used to sit on the other side. Now I work for Halliburton, but I work for the client side also, where sometimes the client is telling me, Sam, I want you to drill faster. There is a limit to that you can, depending on how you optimize your bit performance. And this one is talking on itself, so I won't. Sorry. So what are we finally looking to? Whenever we are making this bit selection, especially in the hypersteer, the type of bit that we have selected there, especially a PDC bit, not a tricone, what we have achieved is one is drilling one section with one bit, increasing the ROP from about 20 to 30%, and increasing the meterage. And most importantly, not leaving any cones in the hole. This is very important because many times you see people are wanting to drill faster. They use tricone bits or even the PDC bits. Sometimes they want to drill faster, but they are not looking at any gauges on that in front of the driller. Finally, what happens? Either you come out with 3 cones left in the well, or you come out with a bit that has had some problems. What does that add up to? You have to spend time to fish those PDC cones, tricone bits, cones, clean up your well bore before you can drill further. Just some practical aspects of why you select a bit. What did this PDC bit do for us as Halliburton? And what are we doing now as I close? We are now working on technologies. One is to improve the temperature at which these bits can work, helping to improve the optimization of our nozzle placements so that your holes can clean better. And then the third is having better gauge protection so that you have a better in-gauge hole rather than a hole that is smaller in size. Thank you for your time. And if you have any questions, maybe I can take on it later. Thank you very much.